Okay, so we're looking at last year's Leaving Cert Chemistry Higher Level Exam 2019 Question 3 Part D. And the question involves working out the relative molecular mass of a volatile liquid. A volatile liquid is a liquid, of course, which is easily vaporized. And for this experiment, it would be a liquid which would have a boiling point less than 100 degrees Celsius. Okay, so effectively, what is the question asked us to do? We're going to have to work out the value of n here. Because we're given 4 of the values. We're given P, which is the pressure. Oh, just bring that in there. P is my pressure. And the pressure value in this particular question is 1.011 by 10 to the 5 pascals. Now, what's absolutely essential here is that the unit is in pascals. The only other unit that could be used is kilopascals, and if it isn't kilopascals, multiply by 1,000 to convert that to pascals. So we must have PA for pressure, PA for pascals, PA for pressure. V is volume, and the volume is the volume of the container that you're using. Now, in this particular circumstance, the volume of the container is 76 centimeters cubed. Now, the volume will nearly always be in centimeters cubed, because it's the most common unit used for volume in chemistry. You must convert this to meters cubed, and to do so, you divide by 1,000,000, or move the decimal point back 6 spaces, and there's my value, 0.000076 meters cubed. So there's my very, very important mnemonic there, PAM cubed. My pressure must be in pascals, and my volume must be in meters cubed. And to go from centimeters cubed to meters cubed, we divide by 1,000,000. N is the number of moles, which is effectively what we have to work out initially. So we'll come back to that. R is the gas constant, which is 8.3 joules per mole per Kelvin. You'll find that value on the front of the Leaving Cert paper. And T is the temperature of the reaction vessel. Now, in this particular question, the temperature value is given as 99 degrees Celsius. And what's absolutely essential is that's converted to kelvins. So we add 273, and that ends up being 372 kelvins. Now, most students will convert to kelvins when they're given a value in degrees Celsius. The R units never have to be changed, but the pressure may have to be changed, and volume nearly always has to be changed to meters cubed. So here's my values going into the actual equation: 372, 8.3, 0.000076, and 1.011 by 10 to 5 pascals. So I'm looking for the number of moles, so I'm just going to rearrange the equation, go N is equal to PV over RT. So therefore, let's work this out. N is P, N is equal to P, 1.011 by 10 to the 5 pascals, multiplying by V. The V value is 0.000076 meters cubed. You can drop the units for this particular part. I'll divide this all by R, which is 8.3, and C, which is 372. Now, you can do that all in one go in your calculator, but what you probably should do is work out the top and bottom separately, because it's very, very simple to make a mistake when you're under pressure in an exam. So when I work at the top there, I get 7.6836, and when I work at the bottom, it's 8.3 multiplied by 372. I have a calculator here next to me, which you cannot see. That's 3087.6. And then, which is my number of moles, this is the number of moles of the volatile liquid which was evaporated. When I divide in there, I get 7.6836, divide that by 3087.6, and I end up with 0.002488 moles. Now, very common question that students ask here is, how many numbers after the decimal point do I take? I just take till I have about 4 or 5 numbers. There's no real cut-off points, so we can take that as our number of moles. So that's the amount of the volatile liquid which was evaporated. Now, to work out the actual relative molecular mass of the volatile liquid, we simply take the mass and we divide by the number of moles. Okay, so we divide by the number of moles. That's my simple formula. The mass is given in the question. This is the mass of the liquid which was evaporated, which was found, and it's 0.22. And we divide by 0.02488. I'll get a unit in grams per mole here, which is the unit of relative molecular mass. So when I do that, I get 0.22 divided by 0.002488, and I end up with 88.4 grams per mole as my relative molecular mass.